Today the lesson is on straight line equations. Before we start, we should have some prior knowledge for this topic. Let me have the y-axis and the x-axis here. You can see a straight line, and we know the form is y equals mx plus c, which is going to be used. And you should be familiar with what m and c stands for. M is the gradient, or you can see the slope of the line, while c stands for the y-intercept. Now from the graph, this is the y-intercept. Please don't confuse with this. This is the x-intercept. For the form y equals mx plus c, the straight line equation, we use the coordinate, the y coordinate from here, which is c. Now the gradient, denoted by the letter m, is given by the formula y2 minus y1 over x2 minus x1. So when you have a line, you can take any 2 points lying on the line. So let me mark this point as A and B. The coordinate of A will be x1, y1. The coordinate of B will be x2, y2. You just have to apply the formula to find the gradient, and as we solve the questions, we will be applying it, and I'll be showing you how to work on it. Now, if you ask me, some of the common errors found while finding the gradient is that you tend to write m is equal to x1 minus y1 over x2 minus y2. You just take the difference of these terms, which is a big no. So these kind of errors should be avoided. It is the change in y. So you can see here, it is a change in y divided by the change in x. Moving on to the next topic, let us consider two parallel lines. I will label them as L1 and L2. You can see they have the same gradient or the same slope. So in these conditions, you can say if M1 is the gradient of line L1 and M2 is the gradient of line L2, so the condition is M1 equal to M2. They have the same slope or the same gradient. We will be using this while solving the questions. Let's talk about perpendicular lines. Again, let me label it as L1 and L2. So this is the point of intersection for both these lines, and you can see they are making a 90 degree. That means the lines are perpendicular to each other. If M1 is the gradient of line L1 and M2 is the gradient of line L2, then the condition is that M1 multiplied by M2 should give you a -1. Now let me use some numbers. For example, if M1 is taking a value equal to 3, then M2 takes a value of 1 by 3 with a negative sign. So it's going to be -1 by 3. Now let's just do the checking. You can see 3 times -1 over 3 giving you a -1. Now the skill that you need here is, for example, if you have 1 by 2 as the gradient for M1, you take the gradient of M2 as, you flip this fraction as 2 by 1. If this is positive, this is going to be negative. Another example, if you have 4, so the gradient of M1 is 4, then the gradient of M2 is going to be 1 by 4. Here it's positive, so this is going to be negative. And similarly, if these values are negative, again you have to just flip the fraction and then you change the sign. Then you have the midpoint formula. Now if you want to find the midpoint or the coordinates of the midpoint C, which lies exactly at equal distance from A and B, so let this coordinate be x comma y. So to find x, you add the x coordinates of A and B and divide it by 2. To get the y coordinate of the midpoint, you add y1 plus y2 divided by 2. So this is the midpoint formula. And then you have the distance formula. Again, you have A at x1 comma y1 and B coordinate is x2 comma y2. So the distance formula, the length of the line segment AB, can be given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now there is no harm in taking x1 minus x2 the whole square or y1 minus y2 the whole square, because the difference is getting squared, so there wouldn't be an issue with the signs. Okay, now we are going to apply all this knowledge into the questions given to find the solution. Let's move on. Question 1. The diagram shows the straight lines L1 and L2. The equation of line L2 is y equal to x. Question 1 is to find the gradient of L1 and the equation of the line L1. Now you can see you have the line L1 here, so make sure you are looking at the right line, not at L2, and this is L1. Okay. Now to find the gradient, starting with the formula, we know the gradient m is equal to y2 minus y1 over x2 minus x1. As a step to find this, looking for two coordinates from the line L1, I would prefer to take these points because it makes the calculation easier and it is quick to identify a point on the y-axis. So your x coordinate is going to be 0 and my y here is 2. From this side, here a point on the x-axis, we know the value for x is 6 and the y coordinate will be 0. So you have the 2 points identified, marking them as x1, y1. This is going to be x2, y2. Substituting into this equation or the formula for the gradient, my y2 is 0, 0 minus 2, my y1 is 2 here, over x2 is 6 minus x1 is 0, giving me a negative 2 over 6. So my gradient simplified gives me negative 1 over 3. Moving on to the next part, the equation of the line. Now to write the equation of the line, we need to find two components to complete this equation, which is m and c. Now since we are talking about the same line L1, we have already found m, which is negative 1 over 3. The next part c is where the line L1 meets the y-axis. So you have the c here, this is the y-intercept. So c is equal to 2. So you can write y equals negative 1 over 3x plus 2. Moving on to the next question. Question 2. The equation of the straight line is 2y equals 4x plus 6. What is the gradient? So the question is to find m. Now we can see that the equation given is not in the form y equals mx plus c, because along with y you have a 2 here. You will have a tendency to quickly write the answer for m as 4, the value that comes with x, which is wrong, because here the equation is not in the form y equals mx plus c, it is 2y. So how can I change this equation to y equals to mx plus c? I will be dividing this equation by 2 on both the sides. So my answer, my equation will look like y equals, the 2 and 2 cancels. Here I'll have a 2 because 4 divided by 2 is 2. Here 6 divided by 2 will give me 3. Now my equation is going to be 2x plus 3. Now I can compare it with the y equals mx plus c form, and I can see y equals 2x plus c, which is telling me my gradient is equal to 2. Moving on to the next question. Question 3.